Hey, Vlad here, devinsidy.com. Welcome to another video. In the previous few videos, we talked a lot about type classes, and today we're going to have a crash course about arguably one of the most known type classes in the Scala ecosystem called ordering. Let's get right into it. All right, so ordering seems to be a very intuitive construct. If one thing is less than the other, well, then it's less. And if it's greater than the other, then it's greater. What's the big deal, right? Well, it turns out that there is an entire branch of mathematics, multiple branches actually, dedicated to ordering alone. So even though it seems to be very intuitive at the first glance, there are actually many details surrounding the topic. We'll actually talk about some of them in my next video, but today we're going to have a very easygoing crash course without diving too deeply into philosophical discussions, as I occasionally tend to do in my videos. I don't know, somehow I'm always trying to find something profound to make videos about. As always, we're in the Ubuntu virtual machine and we're running Sublime Text, the editor of my choosing, which is fully maximized because I'm on a smaller screen, and we're using a wonderful plugin called Terminus, which is running down here, which emulates the entire terminal for us, which we used to run SBT inside of it, and we usually use SBT to rerun the test every time we save the file, but this time we're just going to rerun the tiny main method because we're in a crash course. Let me run you through all the files real quick so that you don't feel lost. So we have the build properties file, which just specifies the SBT version, which is 128, which we switched to a few videos ago. We're using only Scala form as a plugin with these settings. You can pause the video if you want them, but it's the same settings that we have been using in all the other videos. When we go to the build SBT, we're only using the Scala version 2.12.8. We're using the triggered message watch cleared when triggered, which means when we're using continuous compilation or continuous execution, then the terminal will be cleared first so that we see only the last iteration, and we're not using the server feature which was introduced with SBT1, and we have a main method with a tiny hello world project in it. All right, let's start writing some code, and we're actually going to start by looking at some interfaces in Java because the equivalent traits in Scala extend these. So I'm going to open the browser, and I already have a bunch of tabs prepared for this video. So there is an interface called comparable in the Java world, and if we scroll down, we'll see that the only method that it has is called compare2, where a t comes in. So what I'm going to do is I'm going to type it out real quick. So I'm going to pretend like it's our own. I'm going to say our own comparable. Actually, let me collapse the sidebar like this. All right. So, and the only method that it has is the compare2, right? Where some t comes in and an int comes out, and the t is defined over here. Okay, so I just stepped it out so that you always have it on the screen so that you can always see it. Now we will implement instances of this interface for our own types in just a few seconds, but for now what I want to tell you is that Java lang integer, so not ints but Java lang integers in Java, they implement comparable, and there is an implicit conversion in predef, which I'm going to show you right now. Over here it's called int to integer, which converts a regular Scala int into an integer, which means that we can use the comparable method compare2 on integers. So let's do that first. All right, so let me just start out by printing out 10 compared to 15, and then to 10, and then to 5. All right, so as you can see, what comes out is -1, -1 and a 0 and a 1 over here, right? So technically this is not required to return -1, 0, and 1, but this is sort of a convention, right? So technically everything that can come back is, the idea is that if the 10 is less than 15, which it is, then a negative number should come back, and if it's the same, then a 0 should come back, and if 10 is greater than the 5, then a positive number should come back, but it's a convention that -1, 0, and 1 come back. Now this is an old style of programming, and back in the days we had many concerns when we were developing our APIs, and one of those concerns was memory. And it's going to be a bit of an exaggeration, but these days most of the time memory is actually not such a big a concern. So instead of using an integer, we would use something else. So we would go with something like relation, and relation would be an ADT, right? So we would have trait or an abstract class relation, and we would have an object relation. Let me scroll down a bit, and we will have a case object. I can actually type CO, and we would say, for example, less than extends relation, and we would duplicate it a few times, and we would call this equals, and we would call this greater greater than, like this. So this is what we would do today. This solution has way less complexity because we don't have to worry that whoever implements comparable return 37 for some reason and not just one. We can just rely on the convention. An open tab, well, it's not an open tab, but a tab like integer has a very big margin for error, but we're going to talk about this some other time. All right, so let's start implementing it for one of our own types. So actually I'm going to remove relation, and I just need to make sure that I don't use it over here. Let's save real quick. Okay, so I'm just going to have a case class, not CC, that's what I want, a case class person, which just has an h, which is an integer, and it extends comparable of person, not person. All right, so all that it has is a final override def compared to, which gets a person, and an integer comes back. And what we can do is we can use the compare to on the age, right? So we can do this dot age compared to that age. And by the way, notice that today I'm going to use a bit more of the infix notation. Usually I prefer the what's it called, the method called notation, I guess. So instead of writing this, with the parentheses around that, today I'm going to use the infix notation, okay, like this. Okay, so this means that if I position my cursor over here, if I do that, surround this with parentheses, write person over here, go over here, surround this with parentheses, do person over here, we should get exactly the same results. And by the way, there is also another way to implement compare to, which is sort of a naive way, and it is always discussed in tutorials about comparables. You can just take this dot age and subtract that age, right? But so this works sort of the same way. And notice that this time it didn't return, -1 or 1, but it was just a convention, so it's okay to return negative numbers or positive numbers. But you have an issue here was the overflow of the number. So this is a very naive implementation. Usually this is not how you do this. Okay, so let me revert it to that. There we go. Now, obviously, just printing out results is not the most compelling use case for comparable. So what we're going to do now is I'm going to show you what it is usually used for. And it's usually used for sorting. So first, we're going to start with a Java interface, right? So we're going to have a list, which is a Java util arrays as list. This is how you can construct lists these days in Java. So you got 10, 15, sorry, 15, and the 5 like that. And let's print it out. We can print out the list. Let's see. All right, we have 10, 15, and 5. In fact, we actually don't need these anymore. I'm gonna comment them out. Okay. So we can print out the list, and we can print it out again. But before that, we're gonna go to java.util.collections. And we're going to sort the list. Notice that this is a mutable interface, so the list is being sorted in place. Now, because Java is ancient, this code actually doesn't compile, so we actually have to go here, and we have to say that this is not an int, this is actually a Java lang integer, because the generics in Java, they don't work for the so-called primitive types. So we have to explicitly annotate the type so that the Scala compiler will look at the int and convert it into Java lang integer for us. Now let's go and try the same thing with person. So I'm going to mark that, Control D, right, like that, person, like this. And obviously I can't type. There we go. And now we have to change the type over here to person. And there we go. It actually works. It actually works because it looks at the person as Java lang comparable. So if we go to, if we just use comparable of person like this, then it should work. But generics in Java are a bit weird, so it actually doesn't work. But technically, like if this was a Scala interface, then this would only work because a person is actually a comparable of person. In fact, if I go back, in fact, we don't even need to annotate the type, so I can just remove it and it's going to work. In fact, if we don't extend comparable, then it will actually see that it's not going to work. Okay, so it gives us the same message. Cool. Now, before we continue, let me point out a few general knowledge facts about comparable. The first one is that it should be kept consistent with equals. So if compare to returns a 0, then equals also should return a 0. And the second one is that a common gotcha for beginners is when you compare strings and integers. So let me actually go back to int. So let me remove the person over here. Right, like that, like that, like that, and like that. Let's see it. Doesn't work. Why doesn't it work? Because we have to actually go into Java lang integer over here, right? Okay, so what we're gonna have is we're gonna have another list. In fact, let me just copy that one. like this. I'm going to put it over here. I'm going to say this is a list 2, and I'm going to say this is a string. In fact, I'm just going to remove the whole tab annotation. Okay, so I'm going to go here, Control D, surround it with quotes like this. Okay, so we have these two lists, and we're going to sort one of them. And you know what we're going to do? We're going to do that, like that, print out 25, and I'm going to copy these, paste them over here. This one is called list 2, so we're gonna have a 2 over here, right? So this is a typical thing that surprises beginners, because if you have strings that, you know, they look like integers but they're actually strings, then they are sorted by the alphabetical order, right? So 1 1 and then a 5. So if you want to work around this, you would just prepend a 0 over here, right? And then it will sort them exactly the same. So you have 5 10 15, 0 5 10 15, right? So this is actually a very typical thing, you know, if you have a folder, you know, in Windows, for example, and you want to, you know, sort the files in there, and you just, you know, you would just prepend numbers to them, and then you make sure that if you have more than 10 things, that, you know, the first 10, you know, the 0 to 9, or if you start with 1, the first 9, then you start them with a 0. So you have 0 1 until 0 9, or if you have more than 100 files, then you should probably have 0 0 1 and so on and so on. All right, so let me actually press Control Z a few thousand times so we go back to person. There we go. Actually, that should be enough. Okay, person. All right, we have person. Okay, so let's go to the Scala side of that. Let me make sure to remove this. Okay. So Scala has an interface called ordered, which extends comparable, okay? And it looks exactly the same, but it has a method compare instead of compare to, right? So it just delegates to compare to. So let's go back to it, and we're gonna say ordered, right? And instead of compare, we're gonna say, instead of compare to, we're gonna say compare, right? And because integers also are ordered, we can also use compare over here. Now let me make sure to remove this one. We don't need it anymore. Okay, so it has 3 advantages over Java's comparable. The first one, which is kind of obvious, it doesn't only work with the Java interfaces, it also works with the Scala interfaces. So for example, if we go over here and we're gonna print out a list of person 10, 10, person 5, person 15. Okay, we can go to the end of the list over here, and we can say dot sorted, right? So which takes an instance of comparable, and now we see that the list is sorted. So it's not 10 5 15, it's actually 5 10 15. Number 2, since traits in Scala are actually allowed to have concrete members, the ordered trait has all of these 4 methods, and also compared to, obviously, all defined in terms of compare. So if we go back here, we can actually go and let me do this under like this. Okay, so we can print out person of 5 smaller than person 10 or less than, you know. All right, so we have the others, and I'm using Fiora code, so it's going to look amazing. So like this, and greater than or equals, and they all return what you expect. And this all is happening because the order is being extended. All right, so the kind of order that we have been talking about so far is what is known as the natural order. But it turns out that the natural order is sometimes insufficient, and there are many reasons for this. Number 1, what if you don't have access to the class person? What if it's in some other library? Number 2, even though it's natural to sort numbers in the ascending order, sometimes for whatever reasons you might have, you might want to sort them in the reverse order, aka the descending order. Number 3, person might have other members, like for example name, and sometimes you might want to sort by age in both orders, or sometimes by name in both orders, or sometimes you want to figure out some sort of ordering based on both of them. The answer to all of these questions comes in form of an interface from the Java ecosystem called comparator. So we have comparable and we have comparator, and in Scala we have ordered and we have ordering. And in the Java world, comparator is used as an adapter, and in Scala, ordering is used as a type class. So let me actually show it to you. So I'm going to go over here. So we had comparable, and now we have comparator. We scroll down. Comparator has essentially only this one method. We can ignore all the others. They're static anyway. Notice that the comparator has more of the data-oriented interface in contrast to the object-oriented interface, right? So we have a comparable. Something is a comparable, and we call compare to on it, and we pass in the other object. Whereas in comparator, it's its own thing, and we pass in 2 objects, and an integer comes out. Okay, and in Scala we have ordering, which basically looks exactly the same. same. It's over here, trait ordering, and it extends comparator from Java. It also extends partial ordering. So let me go back to my VM, and we're gonna go straight for ordering. We actually don't need the comparator interface from Java. So we're gonna go over here, and we're going to create an object person, which is the companion of person, okay? And we're just going to create an ordering, right? So we're going to call it ordering, right? Ordering of person equals new ordering, right? It's going to be an anonymous class, okay? Because we're going to prefer vals to objects. So all we're going to do is we're going to say final override def compare. So there is a person and there is another person, okay? And then integer comes back like this, and it's going to do the same thing. T.age compare t2.age like this. Okay, let's see if it compiles. It does. And now we can also define another ordering, right? We can go and say reverse ordering, which is an ordering, not print line, ordering of person like this equals ordering dot reverse like this. So and ordering like this one, it has a method called reverse, which just negates this this integer, right? It just multiplies it was a -1. Okay, so now what we can do is we can go over here and we have actually let me start removing stuff like this. Okay, so we have only this one tiny print line, okay, where we have the sorted list. So now we can go to sorted, and we can also specify the ordering. So we can go over here and we could say person dot ordering. Save. It should have behave exactly the same way. And now we can go over here and we can say ordering. I call it reverse ordering, RO, reverse ordering, okay? And now all of a sudden it's ordering in reverse. As you can see, I lied to you before. The method sorted, it actually doesn't want an instance of ordered. It actually wants an instance of ordering. So if we go to the Scala API real quick, and I already have it prepared over here. So this is sorted over here. It actually wants it as an implicit argument. We're going to talk about this in a second. So it wants an ordering. And if we go to ordering, then somewhere in the companion objects, as you can see, this is an object order, and it extends low priority ordering implicits, which is just a trait, which is defined over here. And one of the implicits that it brings is ordered, which takes something that is viewable as a comparable. And remember that ordered, I'm sorry, where is it ordered? Ordered, it extends comparable, right? So this implicit will kick in and will take a comparable and produce an ordering. And this is why this whole thing works, right? So this is why you can just, we managed to call sorted on a list of people without having an ordering before. All right, let me mention a few more things. First of all, it's not required to have to be so explicit about ordering. So you don't need the reverse ordering, for example, right? Because you can always just go over here and you can just say ordering dot reverse like this, right? That's short enough. Number two, it is typical to mark the natural ordering as implicit so that sorted can pick it up, right? Implicit like this. In fact, if we go over here, compare to like this, sorry, like that. Okay, I'm gonna print it out. Yes, it's actually this one, right? So even though person has person is ordered, actually this one will kick in right over here, right? This implicit instance is going to kick in, and we're basically overriding the default compare behavior, right? In fact, we don't actually need person to be ordered anymore, right? We're only going to work with ordering from now on. Let me remove that again, and the braces like that. There we go. Now over here we're being very explicit about where the ordering is coming from. So there's no need because it's because now it's marked as implicit. So we can just go over here and say ordering equals implicitly ordering of person, right? And now we can just use ordering over here instead of that, like this. And as you know from my type classes videos, it is also common to have a companion object for ordering and to have a convenience apply method over there. So you can just say ordering of person and it will behave exactly the same way, right? So the apply method is basically doing exactly the same as the implicitly, but it just looks better. All right, the next point is that because the ordering is a trait with one single abstract method called compare, we can use Scala's compiler to our advantage. So instead of doing all of that stuff, right, we can just go over here and say, okay, there's going to be a function, t1 comes in, t2 comes in, right, and what comes out is t1.age compare t2.age, right? So this is obviously way shorter than this, so we can just throw this out like this, let me do that. Okay. In fact, no, let me leave it. I think we're gonna need it a bit later. And also because these are essentially underscores, right? So we can have an underscore over here, underscore over here. So this becomes shorter and shorter and shorter. Okay, this is exactly the same code. Next one is that the ordering companion object comes with a few useful factories to construct an ordering. So instead of that, let me actually duplicate that. We can go to the ordering companion object, and we have to be careful because we named our val the same way. So I'm going to call it small ordering like this. Okay, so we're going to go to ordering, and it has a method called by, and it also has a method called on. I rarely use on. In fact, I think I never used on, so I'm going to use by. So you can just say ordering by and just pass in the function that takes a person and just maps it to the age, right? So we need to remove this one. Okay, so this is just another way, and again, it's just essentially an underscore. This is very typical. You want to say, okay, I want to order people by age. It reads very, very nicely. The next point is that very often you don't want to construct an explicit ordering and putting it somewhere. You want to just construct it at the spot. And so Scala has another method called sort by, and also there's an equivalent called sort on, right? So you can say sort by over here, right? And then instead of passing the ordering, you can just pass in the lambda that you would pass the ordering, right? So you can do this, okay? And the same here over here. If you want to do reverse, you can just pass it over here like this. And sort by has a second parameter list, so it's a current function. We can go and you can say, okay, give me an ordering event and just reverse it. Okay, so it's going to behave exactly the same way as before. It's actually called sort, not sorted, like that. There's also an alternative way to reverse the order, but it only works with integers, so I don't like it. So you can just put a minus over here, right? So it's basically, it's basically saying, okay, the age is going the other way, right? So this is how reverse works anyway, right? So all it does is it multiplies the integer with a -1 so that the sign flips. As I already mentioned, there's also ordering.on, and there's also sort on, which works with a matching signature. You can always go and check it out, but as I already mentioned, I never needed to use on, so yeah, so I'm happy with by. All right, so one of the last things is that sort by is very useful if you want to sort by multiple things. So let me actually go over here and say that the person doesn't only have an age, it actually also has a name, right? So let me actually remove all of that stuff like that. Okay, so we're going to have people over here, which is just a list of, okay, so it's going to be a person of Alice, 10. Okay, we're gonna have a person Bob, 15, and we're gonna have a person Charlie, 5, like this. Okay, let's see if it compiles. Yep, it does. All right, so now we can print out people, sort by name. It happens because the Scala compiler knows how to sort strings because there's an implicit somewhere, or maybe string actually even extends comparable. Probably does. Anyway, we can keep going like this, so we can do this in reverse like that. So we can say, okay, give me an ordering of string dot reverse like that. Now we can obviously do the same thing with age, and age reverse like that. Ordering of int dot reverse. And by the way, one of the typical things with strings is also to do this. So you can sort by name dot to lowercase, right? So it doesn't matter if you have a capital B here, right? It's still gonna sort them as if it was a smaller one. And notice that it doesn't change it in the person. It just sorts them by a different thing. Okay, it's a very typical thing. I just wanted to show this to you. So what if you wanted to sort by both the name and the age? For example, what if we had another person that had the same age as Alice, for example, right? So we'll go here and we'll say, okay, this is going to be a Daisy, right? We're going to say person Daisy and 10 years old, like this. Okay, so now we're going to go print line over here, and we're going to construct a new list. We're going to say Daisy, we're going to prepend it to the list of people like this, and then we're going to say sort by, and it turns out that we can use tuples, right? This is called implicit derivation, and we talked about this already. So because we know how to sort strings and we know how to sort ints, we for sure know how to sort tuples of strings and ints, or ints and strings. So we can just go here and say, okay, person comes in and a tuple comes out, right? p.age, p.name, right? Like this. In fact, let me have a bit of hyphens over here like that. Let's do 25 like this. All right. Okay, so this is where we are. So we have Charlie 5, Alice 10, Daisy 10. Okay, so these both 10 and 10, they were sorted because we said that we're also going to use the natural order for strings. Okay, but if we went ahead and we wanted to reverse one of them, in fact, the first thing that we're going to do is we're going to reverse both of them. So we're going to go to sort by, and it's going to have an ordering of, this is a tuple of int and string, and we're going to reverse it like this. It's going to be the reverse order. That brace should be over here like this as parenthesis. Okay, so now this is the reverse order of the whole thing. Now this other syntax that I actually didn't like, it is actually kind of helpful over here. For example, if you want to just reverse the age, but you don't want to reverse the names. Okay, so you have the 15, 10, 10, 5, but the names are still Bob, and then over here you have the Alice first and then the Daisy. So age always goes down, 15, 10, 10, 5, but the names, when it can, it goes up. So over here it had a choice, and it made the choice to put the Alice first and then Daisy, because we're still using the natural ordering for strings. Now, as I already mentioned, I actually don't like this one because we can't go over here and we can't say, okay, but I also want to reverse this. Okay, so let's say I want to keep the age, but I want to do this, but this is not going to work because this is a string, right? You can just do a negative string. What the hell is a negative string? So what you end up doing instead is you end up using a custom ordering, right? The same as we did before. So you're going to go to person and you're going to say custom ordering like this. Okay, so we're going to go over here, and this is exactly why I kept this other one, right? So we're going to go here. I'm going to go do that. I'm going to call it custom ordering like that. In fact, I'm going to use lambda instead. So I'm going to use a P1, P2, right? So we're going to say, okay, first do this by age. So we're going to have P1.age compare P2.age, okay? And then if age is already different, by the way, notice this is sphere code, right? So I have the bang and then the equal sign, and it turns into this, which is awesome, right? So if the age, if the ordering by age is already different, then we're good to go, right? So just return this whatever came back, and it's fine. Otherwise, we need to keep comparing, and we want to reverse this one. So what we do is we start with the second one, right? We start with the second one, and we say that name compare p1.name, and I should spell compare properly like this. Okay, I actually made it in such a way that it works was sorted. So we're going to go to sorted. That was the whole point, right? So these factories that the sort by is getting, or ordering by is getting, they're useful most of the time. So most of the times they're not enough, but sometimes they're not enough, and you want to be very, very explicit over here. So this time it's sorted by age. In the natural order, right? So you got 5, 10, 10, 5, 5, 10, 10, 15, right? But the names, when it had the chance, it actually reversed the order of the names, right? So over here, the age is the same, 10, 10, but the ordering of the strings was reversed, Daisy and Alice. Note that implicit derivation also works for other types. So for example, if you know how to sort people, then you also know how to sort options of people. So we can go over here and let me remove all of that stuff. Okay, so for example, we can go and we can say that this is not a list of people, that is actually a list of options. So we put these into sums like that, close the brace over here like that, and like that over here. So we can put a none somewhere in between like this, and we can still print out people dot sorted, and it still works. Okay, so none was the first one, and all the other ones came after that. And the last thing that I'm going to show you is that you can have, so let's retrieve the ordering first, the ordering of person. Okay, so if you import that ordering, and it's very important to have this as a stable identifier, which means it has to be a val or a lazy val, not a def. Okay, so now if we import it, then we actually have convenience methods on people. So we can do a print line person Alice 10, and now we can say, okay, is it smaller than, is it less than person Alice 10 over here again, and it should do, oh my god, what's happening, print line like this, and it should say false. It's not greater, it's actually exactly the same one. Or if it's less than this, that is true. All right, I believe that this is all I got for you today. In the next video, we're actually going to try to make use of ordering. It's been Vlad, devinside.com. Don't forget to like this video if you did, subscribe if you want to improve the developer inside you, and most importantly, take care.